inspired you to become a pilot and also a land speed record driver?
I think there are probably two answers to that, one for each. And I think I would probably say that it was my dad who inspired me to become a pilot. Now, that sounds like an odd thing to say, because he actually said, don't become a pilot, the world's going to run out of oil, it's a very hard job to get into, go and find something more safe and predictable and easier to get into. So he was very much anti the whole thing. But at the same time, it's easy to say that, but of course, I was also, I very much looked up to my dad, and he, one day, many, many years ago, had been a pilot. He actually flew in the RAF many, many years ago. Only for a relatively short few years. He wanted to stay, he wanted then to go and get a job in civilian aviation, but it was very, very hard in the 1940s, 1950s to get a job. So he moved on to other things, became a fireman, became a chief fire officer. But he always talked with passion about flying. That's what started me on flying. I was lucky enough to join the Royal Air Force, fly jet fighters, and I was in the perfect position with the right skills when Richard Noble started looking for a driver for Thrust SSC. And it's difficult to say whether it was Richard and his project or whether it's the amazing British history of John Cobb and Henry Seagrave and Malcolm Campbell and George Easton, all these other incredible record breakers who between them have held for Britain the land speed record for longer than anybody else. And I think I would most identify with Henry Seagrave because he also was a fighter pilot. Admittedly back in 1917 when things were a bit different, but he and I are the only ones who've then gone on to break land speed records. Great inspiration, but I think I would overall say that Richard Noble, as the previous land speed record holder, who then ran the Thrust SSC project, he was my inspiration to take my piloting skills and break a land speed record.
When you became the first and only man to break the sound barrier with Thrust SSC, you inspired many people to study engineering. Why was your call sign Dead Dog?
Probably two questions in there, but I'll cover the second one first. My call sign came from the Royal Air Force. It was a flying call sign, and it goes back to my very first squadron. When it's traditional, when you get new, young, inexperienced pilots, to have a little bit of fun with them and to run a few spoofs and a few practical jokes. And mine was to look after the squadron mascot. We didn't have a squadron mascot, they just borrowed a dog for a few days, and I had to feed it and walk it. And then 2 or 3 days later, they hid the dog, it actually went back to its owner, and I was told that it had died because I poisoned it, and I was in huge trouble, and everybody knew about the story. And it was very funny at the time. And the call sign stuck. So ever since then I called myself Dead Dog, or just Dog for short. It's a very memorable, unique call sign, which is also very useful as a fighter pilot. Moving on then to inspiring other people, which is an unusual thing to do with a name like Dead Dog, but we were incredibly lucky with Thrust SSC to reach out to a generation and be able to show great British engineering on a global stage in 1997. Absolute world-beating, the first car ever to go through the sound barrier, set a supersonic land speed record, and it made us very proud to be British, proud to show off British engineering. And since then, I have managed to meet several engineers who said, I became an engineer because I saw Richard Noble, saw you, watched the car, it's fantastic. And that's what got us fixed on wanting to achieve more this time. And Bloodhound SSC, of course, is about not just setting a 1,000-mile-an-hour record. The Bloodhound project is about inspiring young engineers of the future. And it's going back to what we started to do with Thrust SSC, we're now doing properly.
A few months ago you met Neil Armstrong, the first man on the moon. Did he inspire you, and would you like to go into outer space?
Meeting Neil Armstrong was a huge privilege. He was a remarkable man, and it was inspiring to meet him. From my point of view, I very much relate to him for his piloting skills. He was known as an incredibly cool, very relaxed, very precise pilot who achieved some quite remarkable things. And the flying it took him when he actually took the Eagle, the moon lander, and was approaching the moon for the first time, and the area they picked out to land was incredibly rough. It had boulders, and also, so he's flying this by hand now and by eye, looking for a safe place to land. The fuel is running out and he's only got a few seconds of fuel left. He's looking for a clear area, sees it, right to the last few seconds before he has to abort, and he very calmly just selects the right place, puts it down and lands it on the moon. First time he's ever flown it in that environment, first time anybody's ever landed on the moon, and he is under huge pressure and he does it perfectly. That to me is incredibly inspiring piloting and an extraordinary thing for an astronaut to achieve. Would I like to go into space, fly the space shuttle? Absolutely, I'd love to. But I suspect I probably don't have time to do that and drive Bloodhound SSC, so I'm lucky. I think I've probably got the better deal. I'm hugely looking forward to driving the world's first 1,000-mile-an-hour car.
More than 4,000 schools are following the Bloodhound SSC adventure. How important do you think this project is in inspiring school children?
I think, well, I hope that Project Bloodhound is going to be enormously important in inspiring the next generation of scientists and engineers. 5 years ago, Lord Drayson, who was the Minister for Defence Equipment at the time, threw out a challenge to a huge group of industry and some Royal Air Force personnel at the RAF Museum. And he was worried about not having enough scientists and engineers in the UK to run the MOD for the next 10 years and to run defence industry and British industry, to be able to make service aeroplanes and tanks and ships. We just didn't have the engineering capability. We weren't developing the people to do it. And he wanted an iconic project, something like Concorde or the Harrier or the Spitfire or Apollo, something that would just capture everybody's imagination and make them excited about science and engineering. So Richard Noble and I went to see him and we said, well, we've been talking about this in case somebody was ever to try and break our record. We can build you a 1,000-mile-an-hour car. That will inspire a whole generation of engineers. And, but we'll need to borrow a jet engine from you, a jet fighter engine. So he laughed. He said, well, no, we haven't got any spare jet fighter engines, and actually I don't need a 1,000-mile-an-hour car. What I really need is the engineers. How are you going to get me those engineers? And that is how Project Bloodhound started, because right there in his office, we worked out how we were going to run a land speed record project and take all the science and engineering and put it into education programmes and get it out nationally across every school in the UK through the internet. And actually, because it's on the internet, globally, anybody can have a go and follow it through. So it's the aim of Project Bloodhound is principally to make science and engineering exciting for children of all ages, 6 to 96. Me included, I find it exciting. The way we're going to do that, we're going to build and run a 1,000-mile-an-hour car and let everybody share in the whole adventure.
Why do you think that Britain has produced so many great engineers?
I'm not sure why Britain's produced so many amazing engineers. There is something in our national character that involves scientific challenges and a thought process that wants to resolve those problems. And it has produced itself best in the field of engineering. And we've produced the most remarkable things. The railway and the steam engine. So Watt and Stephenson, etc. The iron ship, the iron bridge, the internet, which, although the Americans claim it, I'm here to reinforce the fact that Tim Berners-Lee, the Brit, actually had the original ideas and the concept behind the internet. Incredible span of science and technology. Why does that work? At some point in the past, we started down a path of science and engineering, and it was very much Britain, possibly because of the British Empire, having the sheer capacity and demand for engineering solutions while we were trying to control about a third of the globe and manage the logistics of moving long distances and the problems of signalling and travelling, and it led an awful lot of our engineering development. We also, of course, had an almost unlimited resource because we owned a third of the globe. It was the largest empire the world has ever seen. It's a good place to start when you're trying to solve engineering and scientific problems. Having started with that background and having started with the habit of having some of the best scientists and engineers in the world, I think it's now very much become a national culture. And unfortunately, in recent times, it has become less of a national culture, and we put less and less emphasis on science and engineering in schools. They are difficult subjects. They require discipline and hard work and long periods of quiet study. They aren't exciting like video games. They aren't easy subjects that get you high ratings for education scores for schools. So it does require challenge, and it is something we need to put a lot of effort into to get young students excited about science and engineering. And that is why Project Bloodhound was created, to try and provide an inspiring mechanism, an inspiring vehicle, if you'll excuse the pun, for allowing students of all ages to study the physics and the science and the maths that they're going to have to study anyway in a very exciting context, the world's first 1,000-mile-an-hour car. Whether it's how fast it goes through a measured mile, which is a mathematical problem, or how the aerodynamics work, which is a physical problem, or whether it is how the structure is put together, which is a mechanical engineering problem. All of those sciences are represented there, and that is, we hope, our contribution to carrying on, keeping Great Britain as the preeminent science and engineering country in the world.
Will there be a corgi model of Bloodhound SOC, and if so, where?
The challenging bit about making a model of Bloodhound is knowing exactly when to do it, because as the design evolves, we've basically got the design in terms of we have a jet engine at the top, rocket engine slung underneath. The rear wheels, we know pretty much exactly where they're going to be, the shape of the front of the car, where the cockpit's going to be, the shape of the intake, all that's fixed. But there's lots of little details, exactly how tall and what shape the fin is going to be. Because until you've done all the aerodynamics for the car, and then you've done all the structural design, so you know where all the components are and how heavy they're going to be, then you can add them all up and work out where the centre of gravity is. To keep the car stable, you have to have the aerodynamic centre behind the centre of gravity. In other words, the fin needs to be big enough to keep the car pointy end forwards into the breeze, so that it will always go in a straight line. That's the last thing, and that's what we're working on right now. So once we've got the shape of the fin and the shape of the back end of the car, because again, once we know what's in the engine bay and how hot the engine's going to be and how hot the Formula 1 engine that powers the rocket pump, once we know all the heat, we know how hot it will get in there, we know how much cooling air we need, we know how much airflow around the back so we can actually shape the back end and the air outlets. Once we've fixed all of those, then we've got the final shape and the last few details, then we can make the model. So I think we're nearly there. We've actually just signed a merchandising contract with a big company down in Bristol, so I'm hoping very soon that we can get a model, because there is one individual in particular I want to send the model to. The first man ever to fly the Blackbird SR-71 sent me a model of his aeroplane signed by him, and I need to send him a model back, so I'm very keen that we start creating those. So I'm hoping, here we are, nearly Easter 2011, certainly by summer of 2011, I'm hoping we'll have models in the shops and available to buy.
You've done so many exciting things. Are you going to write an autobiography to inspire other people?
I'm not sure whether I'm going to end up writing a book or not. I think I may have no choice because there are so many publishers already keen to talk about book deals, and apart from anything else, it may be well on the ways to fund the project. I'm hesitant because it's very easy to write an autobiography, and the way books like that sell is to show how great the individual in the book is. It's very difficult to write an autobiography and spend all your time telling the way you think, which is how great everybody else was. Richard Noble for having the concept for Thrust 2 initially, back in the 1980s, and driving it, and then having the concept for the world's first supersonic car, and then subsequently running the first 1,000-mile-an-hour car project, Bloodhound. Or for Ron Ayres, who actually made the thrust supersonic car possible by inventing and designing the science that would allow us to build the aerodynamic shape, and then subsequently refining that science with Bloodhound SOC. All the amazing achievements of Bloodhound's engineering team, who are managing to build a very strong, very light structure, and the wheels and the thrust. Daniel Jubb, who's producing the largest hybrid rocket ever built in the UK. An incredible group of people, and I feel really privileged to be part of that group. So the problem with writing an autobiography is that the publisher's going to want the Eurofighter pilot, tell us how great it was and how exciting and what you did to break the land speed record and how you're the fastest man on earth. I'm very nervous about doing that because I'd like to tell the story about what a great job that the team did. This is an engineering adventure and I'm lucky to be part of a very, very great engineering team. My job in the engineering is to help with the design, then actually make it work when they take the chocks out and the car starts rolling. But to claim all the credit for that would be completely wrong. So we'll probably end up producing a book. I'm hoping it will be a team book, but we'll let you know.
Thanks, sir, and good luck with the land speed.
Brilliant. Marcus, thank you very much indeed. Thank you for a great set of questions.